We're continuing to solve multi-step inequalities, and we're giving the solutions in interval notation, and we're also drawing a solution graph for the solution set. So let's go ahead and do some more examples. Let's say we're given the inequality 6 times 5x minus 2 is less than or equal to 11 times x plus 3. Okay, so let's go ahead and solve this. We can actually deal with both sides at the same time. We're going to distribute this 6 into the parentheses and distribute this 11 into these parentheses. So let's go ahead and do this. We have 6 times 5x is 30x. 6 times minus 2 is minus 12, which is less than or equal to 11 times x is 11x. 11 times 3 is plus 33. And I like to have my variable on the left-hand side and everything else on the right. So let's go ahead and move 11x to the other side by subtracting 11x from both sides. These two terms cancel. 30 minus 11 is 19. X minus 12 is less than or equal to 33. Let's go ahead and add 12 to both sides. We're starting to move everything else to the right-hand side. Those two terms cancel. We have a 19x on the left-hand side. It's less than or equal to 33 plus 12 is 45. And let's go ahead and finish it off by isolating our x variable by dividing both sides by 19. Those cancel, which leaves us with x is less than or equal to 45 over 19. Okay, so not a whole lot to it. We have 19 here, 14, 11. All right, so we did everything correctly, so we have just an ugly fraction left. That's our solution set. Ugly numbers are actually a way of life, so let's don't get excited here. So let's go ahead and write our interval notation of this solution set. So we're looking for all the numbers that are less than 45 over 19. So we're going to start out all the way in negative infinity, and we want all the values up to 45 over 19. This equal sign says we're including this fraction in our solution set, so we're going to put a bracket right here saying we include the fraction 45 over 19. So that's our interval notation for our solution set to this inequality. Let's see what it looks like on a number line. That goes to negative infinity, that goes to positive infinity. We have 45 over 19 right in the middle. Let's go ahead and write a couple points on both sides. So we have 64 over 19, and we have, what is that, 83 over 19. We have 26 over 19, and we have 7 over 19. So this is going in the negative direction, this is going in the positive direction. So we want all the numbers starting in negative infinity out here, all the way up to 45 over 19. We're including 45 over 19, so we place a bracket here at the point 45 over 19, and it's opening to the left because we're going to shade to the left. We want all the values to the left of 45 over 19. And there's our solution graph. So not a whole lot to it. Let's just do some more practice. Let's say we have the inequality 4 times 4x plus 1 minus 6, and this is greater than 2 times x minus 1 plus 3x. All right, so we have a lot of work cut out for us here, so let's go ahead and take one step at a time. Let's not get excited. We're going to distribute this 4 into the parentheses and this 2 into these parentheses. So let's see what we get. We get 4 times 4x. That's an ugly arrow. 4 times 4x is 16x. We got 4 times 1, which is plus 4. We have our minus 6 is greater than 2 times x is 2x. 2 times minus 1 is minus 2. We have our plus 3x. All right, let's go ahead and what do we have? We can combine some like terms here. So on this side, we have 16x. We have plus 4 and minus 6, which is a minus 2. We have our greater than. Over here, we have 3x and 2x, which is 5x. We have our minus 2, and we can cross these out as we go if it helps. Now, right here we see we have minus 2 on both sides. We can cancel this minus 2, or we can cancel this minus 2 by adding 2 to both sides, or we can just save a step and cancel them out. Anytime we have the same number with the same side on both sides of the equation or both sides of an inequality, we can just cancel them straight just like that. So it just saves us a step. So all we have left here is we can subtract 5x from both sides, which leaves us with 11x is greater than 0. And there's nothing left on this side. Okay, so 11x is greater than 0. If we divide both sides by 11, we just get x is greater than 0. We simply divided both sides by 11, and anytime we divide 0 by any number, we just get 0. So we have 0 in the numerator, so x is greater than 0, so our solution set is the set of all positive numbers, positive real numbers. So let's go ahead and write our solution set. In interval notation, we want all the numbers greater than 0, but not including 0, so just positive numbers. So we have 0 with a parentheses, and that goes all the way to positive infinity. This is the interval notation for the set of all positive real numbers, just in case we use it in the future, which I'm sure we will. Let's take a look at the solution graph of this solution set. We have 0 in the middle. Let's write out a few points just to show direction. This is positive infinity, this is negative infinity. And we want all the numbers greater than 0, so we're not including 0, so we're going to have an open parentheses opening to the right, and we're going to shade everything to the right, which means we're including all the values to the right, or to the positive direction of 0. Alright, so not a whole lot to these. Let's do a couple more. Let's make us some room here. Okay, let's look at the next inequality. The next one we have is 9x minus 4 times 2x. We have another minus 4. This is greater than or equal to minus 5 plus 3 times 2x minus 3. Seems like we're just getting more and more complicated, but this isn't anything to write home about. We know how to do this, so let's just take one step at a time. Let's deal with the parentheses first. So let's distribute this minus 4. Remember, the 4 takes on the operator, so we're distributing a minus 4 into the parentheses. We're distributing a positive 3 into these parentheses. So always want to be careful with our signs. I tend to lose my negative signs, so probably take this a little slow. So we have 9x, we have a minus 4 times a positive 2x gives us a minus 8x. Minus 4 times a minus 4 gives us a positive 16. We have our greater than or equal sign, and we have our minus 5 on the right. Distributing a positive 3 times 2x gives us a positive 6x, and 3 times a minus 3 is a minus 9. All right, in the next step, we have things that we can combine on each side. So we have 9x minus 8x is just x, or 1x. So we have x plus 16 is greater than or equal to. We have 6x over here. And we have minus 5 and minus 9, or you can say plus a negative 9. So we have minus 5 plus a negative 9, which is a minus 14. Let's go ahead and put our variable on the left-hand side and everything else on the right. So we can subtract both sides by minus 6. If you want to in the same step, we can subtract both sides by 16 as well. This cancels, this cancels. We just did 2 steps in one. Hope that didn't confuse you. X minus 6x is minus 5x. We didn't divide by anything, so we didn't multiply or divide anything by a negative number yet, so our inequality sign is still greater than or equal to. And over here we have minus 14 and a minus 16 gives us a minus 30. Now we're dividing by a minus sign. Kind of ironic. So that'll cancel, and we have x flipping our inequality sign because we're dividing by a negative. Greater than or equal to becomes less than or equal to. We cancel these negative signs, so we have a positive 6. So the solution set is x is less than or equal to 6. Now we want to write that in interval notation. So we're looking for all the numbers that are less than or equal to 6. So we're going to start all the way over here in negative infinity, and we want all the values up to 6. And we're going to include 6 because we have an equal sign, so we're going to include a bracket right here. All right, let's see what the solution graph looks like. This goes out to negative infinity, this goes out to positive infinity. We have 6 in the middle, 7, 8, over in this direction we have 5, 4. Okay, so we're looking for all the values that are less than 6. We're going to include 6, so we're going to have an open bracket, and it's going to open to the left because we're going to shade to the left. We want all the values to the left of 6 because this goes in the negative direction. So this is our solution graph. Not a whole lot to it. Let's just do a couple more. We can really get a really good hang of this. 3 times 5x, this is our next inequality, plus 7, plus 6 times x minus 1, and this is greater than x minus the expression 2x minus 3. Okay, so we got a lot to distribute here. We're going to distribute this 3 into these parentheses, the 6 into these parentheses. Here we can go ahead and write in a minus 1. We're just distributing a negative sign, so it's the same thing as multiplying by negative 1, and we can distribute it into those parentheses. All right, so we have 3 times 5x, which is 15x. 3 times 7 is 21, plus 6 times x, which is 6x, and 6 times minus 1 is a minus 6. We have our greater than sign. On the other side, we have x. Minus 1 times 2x is just minus 2x, and minus 1 times minus 3 is plus 3. Negative times negative gives us a positive. Let's go ahead and simplify things by combining like terms. Here we have 15x plus 6x is 21x. We have 21 minus 6 is a positive 15, which is greater than. We have 1x minus 2x, which is a minus 1x, or just minus x, and plus 3. Let's go ahead and move our variable to the left and everything else to the right, so we can add x to both sides. And if you want to in the same step, we can move 15 to the left side or to the right side by subtracting 15 from both sides. This cancels, these two terms cancel, so we have 22x, 21x plus 1x is 22x. We have 3 minus 15 is minus 12. Let's go ahead and divide both sides by a positive 22, which cancels those two terms, just leaving us with x is greater than a minus 12 over 22. Let's go ahead and write it in simplest terms. So x is greater than, if we factor a 2 out of the top and the bottom, we get a negative 6 over 11. And this is our solution set. All right, so let's go ahead and write it in interval notation. We're looking for all the values that are greater than minus 6 over 11. So the lowest value we have is minus 6 over 11, but we're not including it in our solution set. So we put a parentheses right here. We're just interested in all the values greater than minus 6 over 11. So this goes out to positive infinity. And this is our interval solution for this solution set. All right, let's go ahead and look at the number line. Draw a number line and see what that looks like. That goes out to negative infinity. That goes to positive infinity. We have minus 6 over 11 in the middle. We want to write a few points just to so there's no ambiguity as to which direction is positive and which is negative. We have minus 17 over 11. We have minus 28 over 11. We're just going one step in both directions. That's 11. Okay, and then going in this direction, we have 5 over 11 and 16 over 11. All right, so we're looking for the values that are greater than minus 6 over 11. So we're going to be shading everything to the right of minus 6 over 11, and we're not including minus 6 over 11, so we're going to put a parentheses opening to the right there. and then we're shading everything to the right. And that's all there is to it. Very simple. Let's do one more. These are things that, all these things we already know how to do because we dealt with them as far as solving the inequality. We dealt with them in solving multi-step equations, which we have extensive practice with. We're just writing the interval notation and the solution graph of these examples. All right, let's look at one more. Let's say we have 3 over 2 times x minus 1 over 4 times 2x plus 3, and this is less than or equal to 2x minus 4 times x plus 2. It seems like these inequalities are getting longer. So we have 3 over 2x. Let's go ahead and distribute this minus 1 over 4 and distribute this minus 4. Both steps, let's go ahead and do at the same time, watching our signs so we don't lose the negative signs. Minus 1 over 4 times positive 2x is a minus 2/4 x, or just 1 over 2 x. Minus 1/4 times positive 3 is a minus 3 over 4. We're going to get plenty of fractions in this inequality. We have a less than or equal to, so 2x minus 4 times x is 4x, and minus 4 times positive 2 is minus 8. All right, let's go ahead and over here we can combine these two terms. 3 over 2 minus 1 over 2 is 2 over 2, or just 1, so we just have x. We just combine these terms. We have our minus 3/4. One less fraction is always good, so we have 2 less fractions. We have less than or equal to. We can combine 2x and minus 4x to make minus 2x. We have minus 8. Let's move our variable to the left-hand side, everything else to the right. So let's add 2x to both sides. And let's go ahead and save ourselves our step by adding 3/4 to both sides. Plus 3/4 plus 3/4. These two terms cancel, as do these. 1x plus 2x is 3x. Less than or equal to. We have 3 over 4. Let's go ahead and write 8 as a rational number with a denominator of 4. So we have denominator of 4, so 32 over 4. We have 3x is less than or equal to. This gives us minus 29 over 4. Let's divide both sides by 3 to isolate our variable. We'll write 3 as 3 over 1 over here so we can divide by a fraction. Those two terms cancel, just giving us x. We still have our less than or equal to sign. When we're dividing by a fraction, we rewrite the top. We don't ask why, but we flip the second and multiply. So the reciprocal of 3 over 1 is 1 over 3. X is less than or equal to. Minus 29 times 1 is minus 29. 4 times 3 is 12. So again, we're dealing with some ugly fractions here. But this is our solution set, so let's go ahead and write our solution interval. So we're looking for all the numbers that are less than or equal to minus 29 over 12. So we're going to start out all the way over here in negative infinity, and we want all the numbers up to and including minus 29 over 12. So we're going to place a bracket here because that's part of the solution set. And we're running out of time here, so let's hurry up and let's see what our number line looks like. This goes out into negative infinity, this to positive infinity. We have negative 29/12 right in the middle. And let's just go ahead and write 1 point in each direction. Here we have minus 17 over 12, and this minus 41 over 12. And it's 41. Okay. We're looking for all the values that are to the left or to the negative direction of minus 29 over 12, including the point. So we're going to have an open bracket to the left, and we're going to be shading everything to the left of minus 29 over 12. And that's our solution set. All right, so in the next video, we're actually going to be looking at some applications of multi-step inequalities. So get familiar with these, and we'll see you in the next video.